talk about the sets we had listed before. So we listed E was 0, 2, 4, 6, 8, and then L was 0, 1, 2, 3, 4, 5, 6, and O was 1, 2, 3. Okay? We're going to talk about intersection of sets and union of sets, and I need to use all your brain power because you guys will get them mixed up. Okay? Basically, and everyone's really good with it, or people are a little more confused. So, I'm going to get you guys to help me out here. If you are in math, please stand up. Okay. If you are in math and English, stay standing. You are in math and English. So a whole bunch of people sat down, correct? Because you have to be in math and English. You have to be in both to be listed. Do you agree? Okay, so everyone can sit down here. So if it's and, it's both. You have to be in both. That one usually people are really good at. And then you guys get it mixed once we bring in ors. Okay, so and is intersection. Then union is or. So once again, we're going to stand up if we are in social. Yep. If you're in social, stand up. If you're in social or English, stand up. Social or English. So did anyone sit down that was currently standing for social and English? If I said social and English, you'd have to sit down if you were not in both, correct? But social or English, you caught on to that. Social or English, if you're in social or you're in English, you stay standing, correct? If you're in social and English, you still stay standing, correct? You're just extra special. That's all you are, okay? You can sit down. So, and, which is intersection, that's the intersection, that's this symbol. And remember I told you yesterday that the real reason to remember it is to see if it writes the word and. If it can write the word and, I'm glad to lose that. If we can write the word and, it's and, intersection, okay? Now people are like, I don't remember the symbols. Well, look here. It literally tells you on your formula sheet that that symbol is intersection, correct? And we know that if we write the word and, it's and, yes? So they can either say A, the upside down U, B, right? Or they can say A intersection, the word, B. Either way, when they say A intersection B, that throws people off. They're like, I don't know what symbol it is. Yeah, you do. Go to your formula sheet. Intersection is the upside down U. Oh, that's and, right? Don't overthink the problem. Yeah? Now, in order to be an intersection, you have to be in A and B. So the people who are in both, or the numbers that are in both sets, get listed, correct? So it's going to be a smaller set of numbers, usually, unless both sets are the exact same, then it would be the whole set, right? Or is union. And how do I know it's or? Because the symbol is like this, and when I try and write the word and, it's stupid. Therefore, it is or. Okay? That one writes and, that one does not. That one is or. Or often has more in it. Because if I ask the social and English kids to stand up, that's going to be less kids than the social or English, correct? Because if you're in social or you're in English, you stand. That's a lot more kids. But if I say, okay, now only stand if you're in social and English, a lot of those social or English kids are going to sit, correct? So or often has more. Does that make sense? Okay, so let's look at this one. We need to write the intersection. So this time they didn't give me a symbol, they said intersection. If people are like, I don't know what the symbol is. Formula sheet. Formula sheet says the intersection is that upside down U, correct? And we know that's and. So they want us to write the intersection of the sets E and L using appropriate terminology. So that means E intersection L. Right? And the intersection, you can write the word and. We agree? So we need all of the numbers that are in the sets E and L. So I'm going to do the squiggly, aka curly brackets, because the curly brackets mean the setup. One curly bracket means nothing. Two curly brackets where you start with one and you end with one, that means the setup in mathematical terminology. In all mathematics, everywhere in the world, Mars, Jupiter, okay? You make yourself, squiggly brackets means the setup. So in E and L, we have the set of whatever elements, okay? So what is in what elements from E and L, the sets E and L, are in E and in L? E intersection L, yeah?
0, 2, 4, 6.
0, 2, 4, 6. That easy. Close your squiggly brackets, because that means the set of those numbers, right? Now, what if I asked for the number of elements in E and L? You wouldn't list them. What would the answer be? 4, right? That's it. Nothing crazy. So if I went the number of elements, literally wrote the words, or I went N of E and L, that means the same thing. You would say 4. And then a lot of you will do the squiggly brackets. No. The squiggly brackets mean that's an element. So if I did this, which I'm going to take off, so please don't do it. If I did this, that would mean the element 4 is in E and L. Is that what I want? No. I want, oopsies, I want that there are 4 elements in E and L. Do you see where you use the squiggly brackets and where you don't? If I'm listing the actual elements, I'm going to say the set of these elements, squiggly bracket, right? If I'm listing how many there are, I just say there are 4, not 4 is an element in there. The moment you put the curly brackets, you're saying that's an element. 4 isn't what it is one of the elements, but that's not what we were trying to say. Okay? All right. Now the union is that U, and that U cannot be made into the word and, so it is or. It is the set of elements that are a member of the set A or set B, so inclusive. So use appropriate notation to write the union of sets E and L. Do not write the same element more than once. So E, union, L, that means or, correct? So if something is in it twice, we still list it. So if something is in E and it's in L, we still list it, we just only have to list it once, okay? So this is the key thing, put your pencils down. I want everyone to not overthink this. If you have union, if you have or, I don't even list in order. I just go do E and I list everything in E, and then I go to L and I list everything in L. If I've already listed it, I don't list it again. That's it. Or is really easy and everyone does really bad at it. Or is literally go to the first one, list everything, go to the second one, list everything you have listed. That's or. That's how easy it is. Happy birthday. It was yesterday and I missed it. I failed you. My nephew's birthday is the same day and my grandma. A great birthday. I did, and not you. Shame. I feel shame. You know what? Press pause. Pick a candy. Any candy. Look, you might want to choose a specific one. There's Sour Patch Kids. There's Sour Patch Kids Berry. See? I made up for it, right? A little bit. Okay. Whew. Glad we got over that. I don't even know what I was saying. But I saw you and I was like, I saw your little birthday cake. Your little birthday cake. They did. That's why. It's actually what. Yeah, it was truly. Yeah, that's what. I blame that. I saw the birthday cake and I was doing attendance at lunch and I was like, because I clicked on it and I was like, please let it not be today. The birthday cake warrants you for like a week in advance. And I clicked on it. Failed you.
Don't blame anyone.
Okay, I blame Anna for you though. Okay, cool. We're on the same boat. That's the number. All good. It's okay. Anna Kriegel's really lovely. I do love Anna Kriegel. He's a great guy. Super positive, super happy, super fun. You don't know who he is? Go talk to him. He's a VP. Great guy. Wonderful dude. He teaches like social. I feel like Harry Potter every time I see that. Max, it starts recording. You're welcome. Okay, E or L. So I'm going to go to E. I'm your rebel. 0, 2, 4, 6, 8, and then I go to L and I list the ones that are there. 0 already I did. 1, 2 I already did. 3, 4 I already did. 5, 6 I already did, and then I close it. Not gonna lie to you, writing it in this fashion makes my heart die a little bit inside because I really like them in order from lowest to highest. But I have to get past myself Because whenever I do that, I lose you and you don't know what order it is. And when I do it this way, you all get it. So I have to get past the fact that I did not write them in order. Did I just write them over?
If E's superset of L, can't you just write out L? That's still
Oh, a subset of it?
a
Yeah.
subset.
Yeah, absolutely. Okay.
If you do write in order, does that change how it's marked?
No. This makes me die a little inside, but it's totally correct. And then in order makes my like heart sing. But either way, you get a full. So much so that we're ready. Okay, cool. 0, 1, 2, 3, 4, 5, 6, 8. Either way's right. One just seems more right in my heart. On the test, they'll always be listed from low to high in the multiple choice. Just see. Yeah.
Do you use a number on that one, like you do a low one, like and
You can. I like it.
that?
Great thinking. Yeah, no, like it didn't actually didn't do it, but it's a great idea. So I'm using it. N of E or L. This one is perfect to explain it actually, because the last one had 4 elements, and 4 elements can fit into 4 numeric response boxes. So I could literally ask you for the setup. This one I couldn't be able to, right? You can't actually list them in the numeric response. There's too many of them. How many of them are there? 8. And they don't do the brackets because that would mean that they had contain the element 8, and they don't. They have 8 elements. Yeah? Now in the book they use N a lot, the textbook they use N a lot. On the diploma they'll just say the number of elements in E union L. Like they'll say the words, the number of elements in. Okay? So we show the N because the textbook can work quickly that, but they'll say it in words. Okay? Alright. Disjoint sets are super cool. Disjoint sets, the way you show a disjoint set is it's going to be a set that has nothing in it. Okay? Now if I do the union of any sets, well most sets, I should end up with some sort of element, right? Because I'm listing any elements from one and any elements from other, and I'm getting the union. So it's the intersection of sets that often results in a disjoint set. A disjoint set is when I take 2 sets and I take the intersection of them, or the and of them, they have nothing in common. They result in an empty set. So of the 3 above, are there any of these 3 that if I took the intersection or the and of them, they would result in the empty set?
E and O.
E and O, they have nothing in common? True that. O has 1, 3, 5. E does not. Okay? If I did the union of them, would it be empty? No, if I did the union, it would be 0, 2, 4, 6, 8, 1, 3, 5. Right? It'd be all of them. So the union often doesn't result in an empty set. The only way you could get an empty set or a disjoint set if you took the union of sets is if 2 sets were empty themselves. Then they would result in an empty set, which I don't know why we're doing that, but we could. Okay? So, how do we show disjoint? You said it was E and O, correct? Is E and O? Well, so if I go E intersection O, or E intersection O, those are the exact same thing. Do you agree? It's going to equal the empty set. And that's how you prove that they're disjoint. So if they ever ask, determine if these are disjoint sets, determine the following sets are disjoint. Determine means you have to show some work. So if you just say they're disjoint, or they're not disjoint, you're not getting marks. Determine means some work needs to be shown. Well, how do you determine it? You just show that those 2 sets, the intersection, or you use the intersection symbol, result in an empty set, and then you can say therefore, and you can actually do 3 dots in a triangle if you'd like, because in mathematics that means therefore. Or you can write the word therefore. Those are your options. Therefore, E and O are disjoint. Does that make sense to you? Yeah? Okay, and we're going to flip over. Okay. So, these we did before in the example 2. We're going to do it again. universal set are the natural numbers less than 20. So A is divisible by 3, so it's 3, 6, 9, 12, 15, 18. B is divisible by 5, so 5, 10, and 15. And C is a multiple of 6, so 6, 12, and 18. We found these already, right? This is nothing new. Okay. List the elements. So if I'm listing elements, I'm going to do the squiggly brackets because that means the set of, and I list my elements. Do you agree? So I'm going to list the elements of the following sets and describe each set in words. So we'll do the first one together so you know what the heck that means. So I'm going to list the elements, and then I'm going to describe each set in words. So is this intersection or union, first off? Intersection, and if we don't know, that's it. Okay? I know it's intersection. Is that and or? And if I don't remember, oops, I write the word and with it, correct? Okay, so I want to list the elements. If I'm going to list the elements, I'm not just write numbers. To list elements, they have to be in a set. So I do my curly bracket, which means the set of. Now I need the ones that are in A and B. So that's the overlappy ones, right? So in A and B, what overlaps between A and B? 15, that's it. So I've listed the elements, and now I need to describe each set in words. So I want A intersection B. That's it. Okay? Make sense? You guys do 2 and 3. And remember, what does this little A with the apostrophe mean? Complement. And if we forget, it says. Okay? So try it out. So we want what's in A or. So I always write the word below to help me out. A or B, right? And I know it's or because that does not make the word and. We agree? So if I want the ones that are in A or B, like I said, at first when we're learning this, don't overthink it. List the ones that are in A, then go to B and list the ones that are in B, right? Don't overthink it. They can be out of order, even if it's like, my heart is missing. It doesn't matter. My heart's happy you got it right, okay? I don't care if they're out of order. Don't let that mess you. All right. So A or B. So A has 3, 6, 9, 12, 15, 18. And then B has 5, which I haven't done yet, 10, which I haven't done yet, and 15 I already listed, so I don't have to list it again. So does it really matter if they're out of order? No. Does it matter that you have the right numbers? Yes. That gets you 4. Okay? So don't overthink. So this one is A union B. All right. Now, a lot of people will try and do 3 without listing the elements that are in not A. You might miss some, okay? Some people can do it really easily. Some people miss them if they don't do it. So, I know that this is and, because it writes the word and. So I'm going to put and down here. So that means it's the ones that are in bold. So, I'm going to state not A up here. So not A are all the elements that are in the natural numbers less than 20. Natural numbers, what do we start counting at? Naturally, is 1. And then it says less than 20, so I'm going to go up to 19. Okay? So I'm listing from 1 to 19 that are not in A. A has 3, 6, 9, 12, 15, and 18. So I'm not going to list those, but I'm going to list everything from 1 to 19 that is not those, right? Because complements, if you take the complement and it's very, like, complement of A and A, you take them, you should get every number in the universal set, correct? If you take the 2. All right. So not A would have 1, 2, there's 3 in it, 4, 5, there's 6 in it, 7, 8, 9 in it, 10, 11, 12 is in it, 13, 14, 15 is in it, 16, 17, and 19. Okay? Now, we want the numbers that are in not A and B. So they have to be in both. Well, B has only 3 numbers. So if your answer has more than 3 numbers, you're wrong. Okay? Because it has to be in both, and B has 3 numbers, so we can't list more than that in general, right? What the smaller set has for numbers is the maximum you're going to have in your thing, and that means that both of them have all those numbers. Okay? So not A, and we're gonna look at B, and we're gonna pick the numbers that match. So I have 5, and I have 5. I have 10, and I have 10. I have 15 is not in both, correct? So I always go to my smaller set and see what of that smaller set is in the bigger set, right? Because it's just a little easier to interpret it. So this is going to equal 5 and 10. And how I'm going to write this? The complement of A intersection B. So these ones want you to write a set equivalent to. This just is the same thing we did above without the words. So we want the elements in B, what C? And, intersection, right? And it's an and because you can write the word and below it, correct? So we'll do this one first, and then I'll let you try 2 and 3. So B, intersection, or and C. So what's in B and in C? Trick question. Okay. It's an empty set. So what can we say about B and C? An empty set, and they are what? Starts with a D. Disjoint. Yeah. So these result in the empty set when I take the intersection of them. And when that happens, that means that B and C are disjoint. So sometimes on a test, it'll literally just give you different sets, and then the question will be, determine which sets are disjoint, right? And it might, A might be B and C, B might be B and D, C might be A and B, you know what I mean? And so you're going to pick alphabet, and it's a multiple choice, A, B, C, or D, right? So you're trying to figure out which ones are disjoint, okay? That's how they could ask the question. You're doing 2 and 3, go, try that. So this one is A or C. So if it's an A or it's in C, we list it. So A or C equals, A has 3, 6, 9, 12, 15, 18. And C has 6, we already have 12, which we already have 18. So actually, C is a subset of A, right? Everything in C is an A, so then we can just list A. Yeah. Okay, and then this one is A and C. Or intersection. Anything that's in A and C, which is C, right? Because C is a subset of A, so we just 6, 12, and 18. It's very important. Okay, then they gave us a D. Now this is a little more complicated. In order to do this, what you have to do first is order of operations, correct? So you gotta do the brackets first. So I'm gonna do B or D first. Off to the side. So B union D. So if it's in B or it's in D, I'm gonna list it, correct? B has, I believe, 5, 10, and 15. Yeah. So B has 5, 10, 15. And then it has all of these. 2, 4, 6, 8, 10, 12, 14, 16, 18. And then to help myself out, I'm going to list A right here too, because it's above and not 3. So 3, 6, 9, 12, 15, 18. So do you see how I listed A, and I listed B or D? See how I listed both of them? And now I want what between them? Intersection, which is also and, right? Intersection and. We're going to keep repeating these so they're part of our soul by the end of it. So this is and. So I want what's in both, correct? So what's in both? 3? No. 6? No. You see I'm going to the smaller one and comparing it to the larger one? 3 isn't, but 6 is. 6 is. So 6 is. 9 isn't listed out of order, I gotta double check. 12. Yep. 15. Yeah. 18. Oh, no. That's gone. 18. So does it make sense if you list it, the two of them off to the side, it's a lot easier to compare? You guys try number 2, I'll give you about a minute and a half, and then we'll do 3 again. You want to attempt it, you go ahead. Try 2. Remember to list A and B first, which is, what's in A and in B? 15. And then D is listed above. And this is a what? Union, which is a 4. So always use the same words. Union or intersection. Right? So I'm going to list anything that's in this or in that D. So my answer is actually going to be 2, 4, 6, 8, 10, 12, 14, this 15, 16, 18. And then the complement one I want to talk to you about. So we need to do the complements, the intersection of the complements, and then we take what's not that.
Not bad. That doesn't sound terrible at all.
Okay. Not A is everything but 3, 6, 9, 12, 7, 1, 2, not 3, 4, 5, not 6, 7, 8, not 9, 10, 11, not 12, 13, 14, 16, 17, 19. And then not B is everything but 5, 10, and 15, right? So 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14, 16, 17, 18, 19. And we want the intersection, correct? We want the and. So 1, 2, 4, 7, 8, 11, 13, 14, 16, 17, 19. You agree? That's just this. That's just not A and not B. This is like as hard as it can get, just so you know. You can do that. You feel confident in that. Do it. If you're like, it's a little hard, it's because it's hard. Okay? So that's totally fine as well. Not A and not B would be the numbers 1, 2, 4, 7, 8, 11, 13, 14, 16, 17, 19. And then I want, this is crazy, not any of those. So I want everything else, right? So for not A and not B, not, which is why, I don't know, do this because it's good. So I want everything that's not in there, but in 1 to 19, correct? So 1, 2 is in there, so I'm going to go 3, 4 is in there, so 5, 6, 9, 10, 12, 15, 18. So there's a lot of you, when I look at your work, and I say work loosely, you don't have it, okay? I will show work, because then, what if I mess up here? Like, what if I get this right, but then mess up down here? You can get some marks, right? Also, people who don't show work, mistakes happen all the time. We'll lose, okay? We don't want to lose marks, because we didn't show work. So this is your homework, but we're not going to go there right now, because I want to talk about number 4. Can you go to your homework from before, though? Number 4, we're going to discuss it. So, basically, this E, forgot I'm on a different one, I need a pen. Baby, come on, not this. Okay, we're just not going to question it. We're going to just be happy you did it. Okay, so E means element of, right? And this means subset. Very different meanings, correct? Okay. So if something is an element of something, it's listed in the curly brackets. Capital letters are sets. Lowercase letters are the actual little elements. Okay? So let's look at this one. It says little q is an element in A. So I go to A and I see that, oh, little q is an element in A. So that is true. Then it says little q is a subset of A. The only way you can be a subset of something is if they're sets. And little q isn't a set, it's an element. Yeah? Yeah, I'm just gonna go. But yes, you guys did every second one, I think, right? Something like that. I made you do random ones, I believe. Yeah. So this one, this can't be a subset because that isn't a set. That's an element, right? So that would be false. This one, every time you have a Q with a bracket, you could actually replace it with the capital A because they're equal. It says that up there, correct? So if I wanted to make this one, I could go capital A. Capital A is an element of A. No, capital A is a set. So that can't be true, right? So that's false. Little squiggly bracket Q. Little squiggly bracket Q is equal to A. So I'm not going to keep it there. I'm going to write it as an A. Correct? Can A be a subset of itself? Every set can be a subset of itself. So this is actually true. This says Q is not an element in C. So I go to C and there is no Q. So that's true. Squiggly bracket Q. I'm going to replace that with the capital A. It says A is not a subset of D. So that means everything in A is not in D. Okay. So A has Q and D has Q. So actually, A is a subset of D, is it not? So then that's false. This one, A is a subset of B. So everything in A has to be in B, right? So A has Q, B has Q. So is that true? Everything in B is in A. B is a subset of A. B has P, A has N. So that's actually not true. A is an element of D. Can a set be an element? No. If one moment this is a capital letter, it's not true. So that's false. C is not a subset of D. So everything in C is not in D. So C has R, D has that's true. D is a subset of itself. That's true. The empty set is a subset of C. The empty set has nothing in it. So therefore it's true. Because it has nothing in it, it's going to be in C. It's a really weird concept. If you just remember that the empty set is a subset of everything, it'll make your life easier. So the empty set is a subset of all sets. So this is true. Okay? So that's your homework. Work. If there are questions, you have it, will help you.